Hello again and welcome to the next video of section 5, scripting the player movement. In the previous video we've learned how to create a player. In this video we'll discuss how to script the player movement. The game so far features an environment with collision data and a multi-part player object that interacts and responds to this environment. The player, however, cannot yet be controlled, and this section explores controller functionality further. The user will have two main input mechanics, namely movement, walking left and right, and jumping. This input can be read seamlessly and easily using Cross-Platform Input Manager, which is a native Unity asset package. This package was imported at the project creation phase, but it can be imported now via the application menu with Assets, Import Package, Cross-Platform Input. Once imported, open the Standard Assets, Cross-Platform Input Prefabs folder and drag and drop the Mobile Tilt Control Rig prefab to the scene. This prefab lets you read input data across a range of devices, mapping directly to the horizontal and vertical axes that we've already seen in the previous section. Let's now script player controls. To do this, create a new C# script named playercontrol.cs and attach it to the player character. The full source code for this file is given here. The player control class is responsible for handling all player input, making the character move left and right and jump. To achieve player movement, a reference to the rigid body 2D component is retained in the thisBody variable, which is retrieved in the awake function. The movement and motion of the character is set using the rigid body 2D.velocity variable. More information on this variable can be found online at this site. The flip direction function is used to invert the horizontal scale of the sprite, turning it to face left or right as needed, reversing the image direction. For example, 1 and -1. From Unity 5.3 onward, the flip property of the sprite renderer component can be used instead. The fixed update function is used instead of update to update the movement of the player character because we're working with rigid body 2D, a physics-based component. All physics functionality should be updated in fixed update that is invoked at a fixed interval each second as opposed to every frame. More information can be found at the Unity Online documentation at this site. The getGrounded function detects where any circle collider intersects and overlaps with any other collider in the scene on a specific layer. In short, this function indicates whether the player character is touching the ground at the position of the feet. If so, the player is able to jump. Otherwise, the player cannot jump as they are already airborne. Double jumping is not allowed in this game. For the preceding code to work correctly, a few tweaks must be made to both the scene and the player character. Specifically, the getGrounded function requires that the floor area of the level is grouped together on a single layer. This simply means that the level foreground should be on a distinct layer from the other objects. To achieve this, add a new layer named Ground simply by entering Ground in an available type-in field. Now assign the foreground object to the ground layer. Simply select the foreground object and then select the ground layer from the layer drop-down in the Object Inspector. After the foreground object is assigned to the ground layer, the player control script requires us to indicate which layer has been designated for the ground. To achieve this, select the player object and from the Object Inspector, select the ground layer for the ground layer field. In addition, the Feet Collider slot needs assignment too, in order to indicate which collider object should be used for ground collision detection. For this field, you need to drag and drop the Circle Collider component to the Feet Collider slot. Now, give the player character a test run. Simply click on the play icon on the toolbar and test out the controls of the player character. WASD, or the arrow keys, will move the player around. The spacebar makes the character jump. Great! We've successfully scripted the player movement. In the next video, we'll learn about optimization.